Cool. So here's the status right now. Wait, what was I doing? Okay, so I'm just drawing this one Veeam object. Cool, and I see that I edited the fragment shader. So that's just coloring everything red. So I comment this, come back. This is a part of the stroke shader. Okay, so re-implementing the stroke shader stuff is turning out to be a pretty difficult task. I think the first thing that this will require is that I'm gonna have to add a flag, because I'm gonna need to be able to run Grant's shaders and the shaders that I'm writing on my own side by side. So actually, now that I think of it, that actually won't require a flag. What I'll need is an option I can pass to an OpenGL Veeam object. So actually, I can just have something like use projection stroke shaders. I actually won't want it to be true with this one. Let me move this over by like 2. Actually, let me actually set up a shortcut for this. GL.py, next test, quite a few flags here. Quality, probably don't actually need the GUI. I'll keep that. Render equals OpenGL PQ M, I think I want. Okay, see if that does what I want. Cool. Great. Daryl Golden, what's going on? I'm going to move this over so I can fit some more of the flags here so I can actually see them. Alright, the quality flag twice. Not sure if that'll work. Nah, it looks like it didn't work. Oh well. So behind on your stories. What sort of stories? You're rewriting the stroke shaders, yeah, unfortunately. Epigram, you're gonna have to use more obvious language for me. Because I don't know what daily soap is either. The thing with these stroke shaders, I started looking at this a little bit yesterday. Soap opera. Oh, okay, okay, I see. Hopefully they'll work with Intel, yeah. Yeah, that's really weird. I mean, I think there's a pretty decent chance they will if the old shaders don't. Because I was looking into these shaders a little bit yesterday because I was thinking, Like, I had a few options. I could re-implement the shaders. And that would be an approach I could use. But these shaders, the ones Grant wrote, are insane. They're bonkers. They're just like crazy. Did you see the debugging IRF and I tried to do in the Discord? I actually didn't see that. Didn't seem to do with the shaders. Snooze Studios, thanks so much. I actually didn't see that. So I might have to look into that to figure out what it is in that case. You're from the Manim Discord sidebar. Okay, cool. When I go in the Discord, I think it doesn't say that. Like, it doesn't have the purple button. And like, it doesn't say anything, so I'm glad you can see it. But yeah, if it doesn't have to do with the shaders, I might have to look into that some more. But like I was saying, these shaders are nutty. They do so much like projection math by hand. Need the desktop program. What do you mean by the desktop program? Okay, so for one of these options, I'm gonna say carry the blue. What's going on? Vectorized object stroke. Okay, so I'm gonna default the shaders that this is using to back to quadratic Bezier stroke. Like download Discord. Oh, I see. That could be a problem. So I'm gonna switch to quadratic Bezier stroke. This should give me the default shaders. Then this I'll have to update with a flag. Actually, this is gonna get more annoying because this is an attribute of the class, not of the instance. I wonder if I can just like here. Aaron likes to do things by hand. Boy, does he. The bright side is that it's at the point now where there's basically nothing else you could possibly do by hand. I don't think it can get any worse from here. Does any of them have a plugin to at least do syntax highlighting on embedded shader code? I don't... it might exist. But I don't know of a plugin to do that. Just using C highlighting would probably be pretty close. Stroke shader folder, then I'll say self.stroke shader folder equals that. Say he wrote an entire animation engine. Yeah, that he did. Okay, so now that I've added that option, I'm gonna try... this one will be normal. This one... I'll update the stroke folder. Comes up every time. It comes up many times. Because that's just how frustrated I am with it. Also, this is gonna take... I mentioned in the title this is gonna be incredibly frustrating. This will probably take a lot of math. Is this code for fancy OpenGL support? It is. OpenGL render, don't think I need that. Okay. So, here's the... Actually, I think I have to run some tests. The status is I have a shader that creates a Bezier curve. I don't know which one of these it is, though. I have the shader that does it. And this uses pretty much the same technique that Grant's shaders do. The only part that'll be like pretty difficult is getting the caps right. Or the joints, I think is the more technical term. On these intersection points, that actually looks really good. That's not even flat. Well, I sort of suspect that was done on accident. If I use this algorithm naively, meaning that I compute the distance from each pixel or each fragment to the Bezier curve, then all of the line joints will be round. They'll all be round. And actually, even that one wouldn't be enough because of overlaps. And even Grant shaders don't get the overlaps quite right. For example, I think I'm going to put an eye here. And that is very dim. Let me make that less dim. Okay, that's a little better. There are places here and here where the strokes are overlapping. Oh, whoops, wasn't trying to do that. What that means, is that, oh, I already drew it. Kind of. But in places where there's two lines that come together at a point, you can't just find the distance from the fragment to the curve naively. Because if you do, for like a curve like this and a curve like this, and if they have thickness, you know, something like that, and then that. And this overlap is what causes that problem. That's what causes this like this double opacity setting, which isn't what you want. So the hardest part about this is basically figuring out the geometry to prevent that from happening. Now in Grant's shaders do this by emitting a... What's the name of the shape with 5 sides? Pentagon. It emits a pentagon. Usually, but not always. Now if I don't have a geometry shader, I can't emit a pentagon. But with a little bit more work, I think I should be able to. But one thing to check here is, let me switch this back really quick, just to organize my thoughts. So I've looked through Grant's code some, and the way that he emits primitives to be shaded is if this is the Bezier curve, he'll emit a shape something like this. Like this. So this is a pentagon, and then on this shape, he'll compute the distance from each fragment to the curve, and then emit that if that distance is small enough. So the first thing to do is see if I can find a way to emit pentagons like this. And I think if I can get there, then the rest won't be that easy. But I think that's the first step. Very intense. Make it 100% opaque. Yeah. It will be pretty difficult. Let me see if I should be able to make it do one of these pentagons. So let me do a curve from left. Wait, hold on. I'll just label this as like V shape. So I think I'm gonna need that shape for debugging or for testing or something. This, I want to do like a simple curve or something like that. And this one's gonna start at left. Whoops. Left. Then a single curve goes to right. And then the control point will be up. And this will use Grant's shaders. Okay, so that's a simple curve. It's gonna be a high-level polygon library. Yeah, that's what it's gonna end up being. If I go to fragment shader and I Grant's fragment shader. Actually, yeah, Grant's. I should do this on Grant's fragment shader. Pick Bezier stroke. So this is Grant's fragment shader. I'm gonna put this line here. This is gonna shade the entire pentagon red. If I run this, this is the pentagon. This is basically what I was drawing. Wait, why isn't this centered? Did I write some weird code here? Oh, I shifted it. Oh, it live updated. That's neat. Okay, but this is the pentagon. And I think computing one of these won't be terribly difficult. However, this pentagon is... Whoops. The vertices are shifted a little depending on if there's a joint. I think just emitting one of these is a good first step, though. I think that'd be a good first step. So right now, I'm gonna shift this to the left again. And then add in another one that'll use my shaders. The point being, that I can iteratively work on this to see if my shaders are working. That said, my shaders currently don't exist, so right now this is just a copy of Grant's shaders. I want to shift this one to the other side. Okay, so I have to modify this to as close as I can match that. Now you might think that this is as simple as copying the code that he uses to compute those vertices. However, as I said before, his code is bonkers. So wish me luck. I think the magic is happening here. Get corners. Because this has the 5 points of the pentagon, and then it calls get corners to fill that. I think it does something to the corners. Yeah, like scales them or something, but I don't think I need to do that. I also don't know what find joint info does. Oh, I guess it sets whether or not it should bevel or not. Okay, it sets these two things, the bevel type and an angle. Fine. So get corners. Responsible for finding the corners of a bounding region around the Bezier curve. And it can be a triangle fan, that's fine. I wish I could draw. I really wish I could draw and code at the same time. I'm gonna have to see if I can get that set up. Actually, maybe that's possible. Hold on. We're gonna do some fancy schmancy. I wasn't trying to do that. Why in the world did I do it? I think I did it. No, like keep the aspect ratio. Oh my god. Hold on. We're experiencing some technical... Okay, that's perfect. So now I can try to label these variables. Let's see. P0, P1, and P2. Okay, so these are these. The control points. So these are the, probably like something like this. Will be those control points. Then he gets these vectors. P0 minus P1. This is going from 1 to 0. Okay. And this one going from 1 to 2. Okay. From 1 to 0 and 1 to 2. So he has basically these vectors. Well, I guess the vectors just follow this convention. So for example, this is V10 and that is V12. P0 curve pointing to the left of the curve from P0. Left of the curve from P0. pointing to the left of the... P0 is a point. What does it mean to point to the left from a point? Well, anyway, it has this... It's taking V0, 1, which is this vector. Then it's doing basically this negative yx thing. So this should rotate it counterclockwise by 90 degrees. Right. So P0 perp, I think it's this. I put these things in the exact wrong place. Move that. Put that there, I guess. And then this. Why is this line so thin? This, now it's thick. We're experiencing technical difficulties again. This is P0 perp. P2 perp, it's, oh, whoops. Enter the book of shaders. Yeah, I read through that. I actually went through that on stream. Oh, the editor would normally be nice here, but there's so much code that I'd have to bring over that I don't think I'd be able to do it efficiently. Okay, where was I? P2 perp, it's taking V12, which is this one. It's rotating it counterclockwise. So P2 perp will be this. Okay, so basically just collecting that data. I don't think I'm gonna deal with the anti-aliasing stuff yet. Not right now. Then it gets C0, C1, C2, C3. C0 equals P0 minus buff 0. I think buff 0 and buff 2 are just half the thickness. But I should double check that. So this is buff 0. Buff 0. Oh, that's convenient. It's, yeah, it's half the stroke width. I don't know why the stroke widths is an array, but I'm gonna assume I don't have to make it an array. I'm just gonna have that be fixed. Okay, so it's taking P0. I wonder if this is big enough. Should we make that bigger? There's some intense geometry right now. Okay, P0 minus buff 0 times P0 perp plus the anti-alias width times V10. Okay. So the place where it's placing minus buff 0. Okay, let me just draw all this out. This is P0. Buff 0 times P0 perp is basically this length, and it's subtracting it. So that brings you down here. Then it's moving in the direction of the anti-alias width times V10. So it's shifting. It's basically this point. This is C0. And that's shifted a little bit. It shifted a little bit that way for anti-aliasing. But I'm not going to deal with that right now. And the only difference, C1 is only a minus sign, a plus sign instead of a minus sign. So that's C1. It's not trying to do that. C1. C2 is taking P2 plus buff 2 times P2 perp. Then V1, 2. So it's basically this point. C0, C1. So this is C2. And this is going to be C3. That is a weird 3. That's also a weird 3, but whatever. So I get these points. Then it creates the joint. Now the joint will change. The joint will be different depending on the angle of the curve following this one. But I'm just doing the case where there's no following joint or anything. What is this angle? If abs of angle is basically 0, then there's no joint. Angle from prev and angle to next. Where did these values come from? Where are these even written to? Or maybe they're written to here? I don't know what this angle is. Is there any... Maybe this is computed in the vertex shader. Vertex future proof. Let's see what that is. Live GPU editors for shaders. Oops. Okay, that's pretty cool. I don't have the time to set it up right now, of course. But that's pretty neat. Okay, I need to figure out where in the world angle from prev and angle to next came from. Looks like it's not the vertex shader. But I have no idea. What if you can just read files from any of them for future reference? Yeah, hopefully. I mean, so part of the problem with this is that each of these shaders is composed of a bunch of different files. And so you can't just take one. It isn't like one file that has enough information to run it. Is this passed in from the CPU? We go here. Stroke shader wrapper. Isn't there like get this stroke shader data? This doesn't have the angle either. If it lets you compile multiple files, yeah. I have no idea where this stupid angle came from. It's declared as an out here, meaning that the shader outputs it. create joint. It isn't even passed into this. Maybe it only writes to this value? But it doesn't, it uses the angle. Is it here? It gets something called angle between vectors. Here there's an angle and set adjacent info. Oh, and this writes to angle from prev. Why didn't I find that before? Oh, the shader. This function takes in the variable, renames it, and then sets the renamed function here. So that's cool. Anyway. C0 minus adjacent at 1. I'm assuming C0 is some entirely different C0 from the one I already computed. Okay, and so in set adjacent info, I take the 0th control and the tangent, which is the vector going from 0 to 1. Then I take prev, which is the entire curve, the previous curve. And so I'm computing the angle between adjacent at 0 and adjacent at 1 minus adjacent at 0. Wait, why is it doing and then adjacent 2 minus adjacent 1? Oh, this is seeing if the adjacent curve is linear? Why does it need that? I guess then it'll do an auto joint. Although I don't know if auto joint is ever set to true. If joint type is auto joint, where's the joint type even computed? Anyway, I think this is usually bevel joint. The angle between vectors. This is so annoying. The tangent vector isn't computed here. The tangent is computed here. It's going from the 0th control vector to the 1 control vector. And then this is going from the... It's going toward this 0th control point from the adjacent point. I gotta write this out. Okay. Tangent. Controls at 1 minus controls at 0. Controls at 1, that's this one. So this... That's tangent. So I'm going to do the previous one. Then it passes controls at 0, which is that point at the start of the curve. The tangent, which is pointing inward toward the middle of the triangle. And it's getting that. Then this vector, C0 minus adjacent at 1. I think that would be if there's another curve here, like some other curve. Then it's taking the midpoint or the control point of the adjacent vector and subtracting C0, so it's going that way. And it's getting the angle between these two vectors. And it's using that to compute the joint. Okay, sure. Although, wait, let me see. So that's set adjacent info. And that's in find joint info. Then that's passed to, well, after that, there's get corners, which calls create joint, which uses the angle at which the previous and following Bezier curves intersect the current Bezier curve. Then it uses that to compute a shift to modify C0, basically. So that's where the shift is going to happen. Well, I hope I can do all of that. I think if I don't handle any of the shifting stuff, this should be somewhat doable. Okay. The vectorized object stroke. Although there's a problem right off the bat. I can't transmit a polygon using only a vertex shader. So my options are either one, I can, instead of transmitting a polygon, because Grant shaders transmit a shape like this, which isn't a triangle. What I could do is transmit a triangle that contains the entire pentagon, then compute these points inside the vertex shader, and then do the same thing. Or I should learn how to use this stupid thing. How do I move it? There. Or I could find a way to triangulate that shape. So there's this shape, and instead of transmitting the whole thing, I could send in 3 triangles, which that arm looks kind of weird, but like that, which would increase the number of points that I send in, triple the number. So maybe I don't want to do that. I'm going to try computing the points. I'm going to try computing the 5 points within the vertex shader. So here's what will happen. If this is the Bezier curve, then I'll be passed in the control points. What I'm going to try to do is within the vertex shader, compute each of these 5 points, then transform each of these so that they map onto the points in the larger triangle. That's the game plan. Yep. I hate my life. Okay. I think I can just delete these files. What do I get? I get the point, pre-point, next point. Euclid's Elements. You'd think so. I wanted to do a video on this book, but Manim was too broken, so I ended up trying to fix Manim instead. Brief point, next point. I think I want all this data still. There isn't one. There's probably, someone's probably done it at some point. Man, I basically want to just delete all of this. Vectorize object stroke. I'm just gonna destroy that. Get the default one. Surprise Grant has it. Yeah. Yeah, that seems like something he would do. GLSL. I'm gonna just delete this. Just the geometry shader. And for the vertex shader. So this is what it is right now. I have to pass in my uniforms. Let's see. Maybe I just want another thing. So here I just say, if it's an OpenGL object, OpenGL Vim object, I'm just gonna do this. Maybe I want to do the same thing here. I probably do. There's no real reason to go through meshes anymore, at least for this. Render OpenGL vectorized object fill. What does this do? Stroke data. Point, pre-point. Next point. And then the color stroke width, stroke normal. I'll probably use the same code. I'm gonna do it. I'm gonna try to write my own function for it. Yeah. That'd probably be more flexible than doing the shader wrappers. Honestly, I want to sort of move away from shader wrappers. They're not that great of an abstraction. Okay, with that in mind, I'm gonna start from the test code. So render this fill, render the stroke. Great. Then I have to go to that file. Is this the one for the fill? And it finds the layers. And does the fill and the stroke. Layer to stencil VAO. And then texture to fill VAO. Okay. What I want to do is write this function. And this is gonna have to do not all of the rendering. No, it will do all the rendering. Great. Self and mobject. This is going to take a renderer and the mobject. So just to get the smallest example of this going, just to use the test shaders, I'm gonna try rendering, try just something from the examples, see if I can use the, and there's no example that uses the test shaders. How delightful. This one uses Manim chords. Maybe I can just use that. Since I'm going to end up using the projection matrices anyway. Okay, then I'll just use the corresponding fragment shader. Great. Now I can mostly just copy this. Although, I think I'm doing the wrong check here. I'm just gonna make this pass. I only want to render a object using those new shaders, the new shaders I'm writing. This is if object.render folder or stroke render folder or whatever I called it. Stroke shader folder. Goes vectorized object stroke. And do this. Maybe all I actually need, actually. This is in render object. What's the end goal? Just having an API for rendering all the Manim primitives. In this particular file, that is... Yeah, I think that's the end goal. It's something to render all the Manim primitives. And there aren't that many of them. Basically everything is vectorized objects. But for vectorized objects, surfaces should probably eventually be standardized this way. Image objects. And then meshes. Although meshes are sort of a... Meshes should probably never go away. It's like a compatibility layer to access the OpenGL renderer fairly straightforwardly, in a fairly direct way. Okay, so I have this stroke. If it's this, then I want to do that and then return. Else, it'll go through and I'll do this and I'll render its fill this way, which right now there's no fill. I should also probably like to do skip this step if alpha is 0. I think that the 3 blue and brown version does that. Okay, but if I set that, then it's going to use this function. Otherwise, it'll skip over this and render normally. So let me see if that works. Great. So this is Grant shaders that I modified a little. Then the other one doesn't appear. Because this rendering function doesn't do anything. So let me try to fix that. I'll pull the renderer, do this. Pull the camera. there. Wait, where did the other shader get the... Oh, the other shader also pulled this from the camera. So passing the model view matrix. Okay. OpenGL perspective projection matrix. Let me see what the other code did for the projection matrix. Pulled it from the camera, so I should probably do that. Okay, so set that, set that. Attributes are... It's just a square. Then a mesh? I think I'm not going to make a mesh. Instead, I'm just going to make the vertex array object directly. So pull this. Into our context. So vertex buffer object for the vertices. I think that's all I need, actually. For the data type, I think I can pull that from the shader. I think I just called the shader. We can pull this from the renderer. The data type names. Where did I get that from before? I guess I can just pull it from the vertices array. So like this. Okay, then once I have that, I'm just gonna render it to the screen, like so. So use that, basically this exactly. Use the screens frame buffer, render from the VAO, then release the two of them. Let's see if that works. Hey, it worked, that's great. So now I'm gonna have to actually parse the data from the actual mobject. Okay. Okay. So I think the data that I take will be essentially the same data coming from the stroke shader wrapper here. Oh my gosh. Here, okay, stroke shader data, this. And this will give me the point, previous point, next point. Color, stroke width, stroke normal. I think that's everything I want. A unit normal. What is this function? Read data to shader. Oh, this is something defined in mobject. Though I don't think it's very complicated. Num points per cubic curve. Points per curve. Okay, I'm just gonna take this verbatim and see if I can't shoehorn this into the way I want it. D-type. I think I could just... Maybe I should just import that. I don't think the stroke D type... Maybe I could just hard code that. I don't think this will ever change. What did I do with the fill? For the fill, I just hard coded it. Hard coded it twice. Don't think that data really changes. I'll just hard code it. Okay, so then there's the point, preview point, preview point, next point, unit normal, stroke width. Guess I don't need this on the screen anymore. If I can figure out how to get rid of it. Cool. Alright, thanks Evergram. See you later. Okay, so set basically all of the point data. To get the rest of it, I guess I have to follow this function, read data to shader. Oh, and this has a concept of locked keys. Maybe I should do that. Actually lock the keys. But I think I'll deal with that later. It mostly just checks this data alignment, then just sets this data on the shader. So it's setting the uniform. Okay, setting a uniform. Oh my gosh. Oh, I didn't delete anything important. That's lucky. Okay, so this didn't break anything. If I set a uniform, that'll start breaking things. Let's do like shader. Let's say uniform. Like color. Set like color to this. I think you actually have to set this in a weird way. I'm gonna do that. The tuple indexed at 0. Pretty sure just that will break it. Oh, it didn't. That's lucky. So the color, the stroke width, and a unit normal. So I'll see if I can... I don't know if this is where this data is located. Object.data at stroke width. I guess that seems right. Yeah, it's looking at data. Okay, so try that. That works. Man, I keep doing that. And finally, the unit normal. I'll just call that normal. I'm not sure how that normal is used, but whatever. Okay, then I got to change this shader to a way where it can take these vertices without crashing. Because I know if I do like in... Oh, well, wait. Um, I try to take in the point. Wait, what? Oh, I'm only using I'm using the Manim chord shader directly. So I'm gonna want to copy that shader into the vectorized object shaders that I'm putting together. Let me do that. So just read that in. Then try to find the fragment shader underneath all these files. There. But that should be able to switch this to vectorized object stroke. And I broke something? Oh, and I think that actually makes sense. Unfortunately. Unit normal. Wait, that actually makes less sense. Key error normal? Okay, I guess the shader... I thought this thing was, I thought this was error checked. Yeah. That's weird. So what happened here? I did shader.set uniform whatever. Oh, it's talking about in the mobject. That should be unit normal. Okay, so that does work. I think I'll just call that normal. Great. Then I have to swap out these attribute arrays. Which is bound to be annoying. Because it means I have to use all of this data. Stroke width and color. I don't think I need the color to be in the vertices. Maybe eventually I'd want to do that. But not right now. Or the unit normal. I don't think that needs to be in the vertices either. Yeah, I'm not going to do that for now. Or the stroke width. And so I was looking for like varying width. If I was looking for varying width lines. I'm not trying to do that right now either. So that actually simplifies this quite a bit. I've already passed in this data. Okay. Now I have to, unfortunately, I have to switch these out. To start, I gotta start by just switching this invert with point. Points? Point. Singular. Here and here. Then this, I'll switch to point. Run it that way. Great. As for prev point and next point, I don't know how I'm going to figure out how to use those. But the time has come. I have to switch attributes for points. Or for stroke data. Wait, hold on. That's a weird substitution to have. It should just be here. Isn't this variable only used once? Oh no, it's they take the length of it. Okay, I guess that does make sense. Sort of. Oh no, it's actually used a ton. Yeah, okay, that makes sense. Okay, let me try to replace this with stroke data. This is going to break. Okay. Key area previous point. Meaning, previous point is not used in the shader, so it has an issue with me passing it in here. I don't even know the data type of any of these. So this is a vectorized magic stroke. Don't need that anymore. What's this? Do need that. I have way too many files open. Don't need that. Probably don't need that or that. Then let me open the quadratic Bezier stroke. This vertex shader. I guess they just vectories. I'll copy that straight from there. Put it here. Okay, now there's a vec3, I guess. Which that'll be fine. Okay, so now it's taking in all that data. I think this is still an error. Size mismatch for matrix multiplication. I actually didn't think it would get that far. Thought it would crash before it even reached the matrix multiplication. But this isn't super hard. I can just add a 1 there. Okay, let's see how that does. Okay, now it's saying can't set a previous point. Or I didn't use the previous point. So if you don't use... I think I actually do want this to be called a unit normal. If you don't use a variable, at least in modern GL, I don't know if this is a general thing, but if you don't use a variable, then it's optimized out. And the result is when you try to set it, I mean, if you try to run the program when that's not set, or you try to run the program and it is set, then it'll crash because it's optimized out. I actually don't think I want to do this transformation. I think this transformation would be the last thing I want to do. Because this is converting into clip space, I guess. And I want to do all the computations in mostly in Manim space. Yeah, let me just put in some random if statement or something. Let's say if retrieve point at 0, it's greater than 0. What if I can just do nothing? And like, same thing with next. See if this works. Pre-point, next point, unit normal. And I'm using point down there, but I'd rather just do that. See if that runs. And it doesn't, guess it's too clever for that. Maybe I can just set a variable or something. Or like int x equals 0. And just like do that. There's no attribute value. What? Attribute object has no attribute value. Remember that key.value. Self.shader. Some problem with setting a shader. Setting specifically the unit normal. What problem is there with that? Object at data at unit normal. Members of key.value. It's an error from the internal library. But it occurs when I try to set unit normal to this value. I wonder if the name... No, it says here that it's supposed to unit normal. Oh, I think there should be a tuple, so I guess I'll try that. Since there's 3 values. Same thing. No, the same line. Oh, it's not a uniform. Okay, so make that a uniform. I would expect I'd still have to wrap it in tuple, but let's see if that works better now. Man, still. Why should I data at unit normal? And this time it is used. I think, yeah. Did I set the color? Yeah, I set that. What if I just don't set this? Okay, then it works. So now, why is this single line not working? Oh, I didn't save it. Better? Okay. So now I'm just using the points of the Bezier curve to draw the triangle. Okay. So now, the point, previous point, and next point. Okay, I think these are bad names. I think. Wait. How does this shader get the vertices of the following? Of the previous points? The previous points and the next points? Because if I look at the shader, Oh, this has its own inputs? Previous BP, BP, next BP. Where did it get those? Position point into frame. Wait, what? Here, it looks like BP is an array of 3 vectors. But in the vertex shader, it's only 1. So that's kind of weird. Where did it get the rest of that data? I have to look at this again. Reeve BP. Why is this an array? How is that possible? This must be something about... The geometry shader must be doing this automatically somehow. Darn. And I don't really know how. Reeve point. Points. I'm going to have to print out what this data type is. Because it looks like this is only passing 3 points for the current quadratic Bezier curve, but I need the 3 points of the current, the previous, and the following, I think, or at least the tangent curves. So go here. Comment that, just go here. Here, I'll have to debug that. Oh, that didn't work. Great. If I print stroke data, stroke data at 0, 1, 1, 1. Okay. Oh, stroke data at point I want to do. So 1, 0, 2, 1, 3, 0. These are the vertex locations. These are the locations of the 3 points, the 3 control points. But it doesn't have the previous data or the following data. So that's annoying. I guess I'll have to do that on my own. Because as far as I can tell, the geometry shader is doing that automatically. This receives 3 previous ones, I guess. Even though the vertex shader only outputs 1. I wonder if it's something you can configure about geometry shaders that'll take like 3 points or something. Also, these are bad names. Okay, because it's not... yeah, whatever. Okay, so how can I do this? First thing, I have to give these better names because this is all the same. I wonder if... Okay, if I do an in vec 3... Is this for like an array of them? I do this like curve? Because I want maybe to be like this if it's C-like. Because I want an array of 3 vec3s. So this will be 9 values. I'm gonna go here and just see if that even makes sense. If we look at the members. And it's not even here. Did I forget to save or something? No, it's there. Stroke shader folder. Wait, that's a really weird way to fail. Does this run? Oh man, something else is broken now. What did I change? Object stroke folder. That stroke shader folder equals that. That's a weird thing to change. Okay, guess I'll try that again. Okay, some object has no stroke shader folder. I know vectorized objects do. During the wait. Okay, I'm gonna have to print out this object. I have no idea what's doing this. That's the wrong thing. Where's jail renderer? Here, I want to print that object. I have no idea what's causing that. A mobject object? Where did that come from? Is this like the mouse point or something random like that? This was just working. Render OpenGL vectorized object stroke. Did I self.add something? Okay, I'm gonna have to debug that. What is this mobject? It has empty data. So the last thing to be added, I guess. I have no idea. This is gonna be something really dumb. I guess I'm putting everything on pause while I figure out where this came from. It's scene.mobjects called from update frame. That's gonna call from scene.py. Or not. Oh, that's called from render. From self.moving objects. I keep doing this the old way. Okay. Here, it's already added. Okay, that's from play internal. This is in play. Guess I'll check it here. Here it isn't there. So I'm gonna start from here and see where that was added. Is there a way to print something on every step? Nah, I won't bother doing that. I bet it was in this add objects from animations. Of course it was. I hate that function. Well, I hate everything in the scene caching file. Anyway, caching.py31. Add objects from animations. Here. Okay, I have no idea why this would add an additional object. But let's see. Here there's only two. Animation. How does the wait animation have a mobject? Someone did something weird again. Okay, let's look at animation.py. What is the mobject for this? Self.mobject.shader wrapper list. Did this not work in OpenGL? This isn't the way to fix it in any case. Let's look here. Months ago. Guess it's been here a while. Is static wait false? Did wait not work in OpenGL? Manim.mobject for anim and self.animations. I guess this isn't the worst thing in the world. But it's a pretty bad hack. Yeah, it's pretty bad. Anyway, if I go back to OpenGL render, just add has Atcher. I forgot what I was even doing. Oh yeah, that's that shader I'm trying to work out. Here's where I'm starting it. I was trying to set the curve. Great, so there's a triangle. Then I want to print the members. Yeah, it still doesn't have the curve thing, member. Which is unfortunate. Oh, I didn't set it. Let me try setting this again. And it still doesn't have it. Dang. So I tried to do stroke data curve at like 0. And then try to set something. Fully expect this to fail. Yeah. Oh well. I hope there is a way to pass an array of vectors. Or maybe you just have to use a matrix for that? Arrays can be declared multidimensionally. Do they have to be uniforms? They're structs. So I guess I could have three vec3s and a struct? Oh, but I put the syntax wrong. It should be like this. So now if I try that, well, it worked. But the curve member still isn't there, dang. If I just try to write to that anyway. Now, well, it obviously wouldn't work if I try to write it anyway, actually. Next point, pre-point, and point. Yeah, looks like that's the only ones it has. If I did this... Oh, it still doesn't appear. Oh, it must be getting optimized out. Oh, also that's the wrong shader. Oh my gosh. Close that. Okay, try that again. Although I still don't see it. Oh my gosh. This thing's really making life hard for me. Current curve at 0. I'll say at 0. Hey, it's there now. Great. Man. So then what will I even want to do here? Because I don't know how to pass this data. I think all I need to do... something like this. I do a current curve and make this 9 floats. I don't even know how to set this. Oh. Go to BDB here. Okay, so if I look at point. Okay, now what if I look at pre-point? Next point? Okay, so that's setting it to itself. Fine. Guess I can do stroke. Data. I'll just do for I in range 3. And right to current curve. This will be a tuple. And this will just be tuple of like the range 9. See if that even runs. Oh yeah, that'll continue. Guess it's running. Although I don't know if that's that data is actually being set. Let's see. I guess I have to do some sort of if statement here. Let me make this take an N, the color. Let's just output that. Let's say v color equals some random thing. Okay, so it's here to be red. If I get else and make it blue. Okay. So here I would expect it to be red, I guess. No, it's blue. 0 at 0 greater than 0. And it's equal to 0. So that does make sense. So maybe this one's red. Okay. So if I did 1 at 0, and that should be 3. Okay. This one should be 4. So that makes sense. And then this one should be 6, 7, 8. So this one's 6. 7. And 8. Okay, so it's not super hard to write to this. Now I just need for each point, I'm gonna need the 3 points be the 3 prior points, the 3 points, and the 3 following points. Although I don't really need that. All I need is the tangent vector, I think. I think there's a place with a geometry. I'll just pass all of them. There might be a place with a geometry shader. Let me just look. If I look at prev and next BP, this uses all 3 of them. Then it passes to get reduced control points, then it passes that to prev. Then this prev goes into flatten points. Get the flat prev goes into find joint info. And these controls has the prev and the next. Prev at 2 minus controls at 0. Okay, so it uses at least the 0 and 2 points. Okay, then it'll need the middle point for computing tangents. So I do need all of them. So the next question is, how do I send all of those points for each entry? Maybe all this requires it's doing this. Equals points. Oh, this isn't gonna work. I'm gonna want that data to be repeated. Well, maybe it would. Current curve up to negative NPPC. And this is complicated because what I want I guess this is already here. What I want is stroke data. Current curve at 0. Okay. That needs to be like points at 0. points at 1, points at 2, and then all of that again. Then points at 3, points at 4, points at 5. I'm gonna get rid of all the points at. I hope. Something like this. 0, 1, 2. Then for the falling one. This will be 0 and 2, 3, 4, 5, and then 6, 7, 8. And this one will be 3, 4, 5. 6, 7, 8. Then 6, 7, 8 again. It's a weird pattern. Most of them it'll just index into some point in the points. But not all. Maybe try doing... It's kind of hard to do with only one curve. Maybe I should just do one with more curves so I can test this. There's got to be like points indexed. Now, how can I do this in a loop? Or without doing a loop? I need to do like some sort of weird slicing syntax. Or like stacking? Man, I do not know how to manage these windows. Close that one. I'll deal with this. So let's see points. It's this. Yeah, I'm gonna have to do something with more points. Maybe I set up points 2 or something. Just so that I can see all of these. Wasn't trying to do that. I can just set this to 1.0. Like this? And just repeat this down to 9. So break after that. I think I'll just call this P. Quit that. Run it again. Okay, so there's that. Interestingly, I want the curve data or whatever it was called. Current curve. I want current curve at 1 to be just the entire points array. But let me try to stack this, I guess. I wonder if there's like a shifting function in NumPy. Roll. Roll x2. So this makes it wrap around. Reintroduced at the first. Interesting. E dot roll. I did like 3. NumPy dot roll. Do I have NumPy? NumPy? Okay. P by 3. Okay, so I guess I'd have to do 9. Maybe 3 if the axis equals 0? Okay. And if it's a closed shape, that's probably what I want, actually. So the... let me look at P again. For the 0th curve, which is these 3 points, the previous is 7, 8, 9. Then I want the 1, 2, 3, then the 4, 5, 6. So it's exactly this. So I basically want stroke it at 0 equals numpy.roll p3 axis equals 3. What do I want for these other ones? I look at P for the first entry. Wait, this isn't right. I was thinking about this whole thing wrong. Each of these individually is a single point. So this is a curve. Right. So I want stroke data at 0 just to be P indexed at up to here. Then at 1 I want it 3 to 6. Then here 6 to 9. This is what I'd want. Stroke data at current curve, I guess. How can I do that and do that in general? I wonder if this still runs. At least gets that far. Oh, something broke from 3, 3 into 9. Let's see if I can do this with 3, 3. Okay, then if I look at stroke data, current curve, Okay, that's actually exactly what I want. Okay, so I think all I need to do is find a way to split this. Split that 2-dimensional array into a 3-dimensional array along the 0 axis. So there should be like a V-split or something, I think. Ah, but it doesn't output a NumPy array. There's a reshape. So I look at points. This makes sense. If I did numpy dot or p dot reshape, and I want this to be 3 by 3 by 3. Oh, not p, but points. That is frustrating. If it's too small, then it just won't work. What if I just want 3 by 3 by whatever? That worked. So numpy 3 reshape. Maybe I can just look through the documentation on this. New shape should be compatible with the original shape. If an integer, then so it will be a 1D array. One shape dimension can be -1. In this case, the value is inferred from the length of the array. Okay, so I think I want points.reshape, or like numpy.reshape. Points, this should be 3 by 3 by negative. Oh no! I bound my negative sign. I'm surprised we didn't run into this problem earlier. Dang. I should just bind something else. Oh, now I don't know how to make a negative sign. Wait, have I never run into this before? Have I never tried to oh, I can do it in insert mode. I just can't do it in this terminal. That is really annoying, actually. Well, okay. I'll have to fix that. Okay, that points.numpy.reshape. Points 3 by 3 by -1. Darn. Why did it do that? It isn't 3 by 3. Is it? No, it's not. Isn't this index order? I guess reshape can still do what I want. It's just that if it's only 1, then it won't work. Let me see if I do this with P. Yeah, then this is 3 by 3 by -1. Then it works. I assume that would also work if P was even longer. P 3 by 3, and -1. Nope, that completely didn't work. These axes aren't what I think they are. I think I want -1 by 3 by 3. It must be with this index order. The last axis changing, the last axis index changing the fastest. Okay. So maybe now points just what I want. Okay. So I think what I want to do is say stroke data at current curve equals np.reshape of points Wait, hold on. Yeah, okay. Reshape of points -133. And I think that's actually all. Hope that's all. I'm gonna print that. Okay, then it has itself, and itself, which it has to have, because it's only 1 point. Okay, I think that's good. I think that's what I want. So let's look at stroke data at current curve. Okay, numpy.reshape. P. Oh, I still can't type the negative. Yeah, quit that. -133. So that's perfect. How can I do the previous and the next? I think all I need to do is numpy.roll of this. By like 1 and axis equals 0. Well, that did not do what I wanted. So axis equals 0. Yeah, and this has the previous. If I did -1, then this is the next. So I go here, go that current curve, previous curve, next curve. Previous curve, next curve. Then I'll just do this with these, not that. Current curve, yeah. Previous curve. Next curve. I actually just have this here just so I'm always using it. Okay, so when I had the 1, I think that was the previous. So to shape this the way I want, call this like curves array. Or just curves. Sweet. NumPy.reshape points, the matrix points with -1, 3, 3. Then, so let me order it this way. Previous, current, next. Previous, current, this will be the next. And the current will just be curves, because it's already been reshaped. And this will be curves.roll 1 and axis equals 0. Yeah, and this will give the previous. Then here, curves.roll -1, axis equals 0. And with that, previous, current, next. These are all 3 by 3. Okay, this is the way I actually want that data to be structured. And let me do this with P. And then I'll break there, save this. And I did something wrong. Oh, yeah. Sweet, np.roll. Same thing. Now broadcast from 433 into 333. Weird. I think... Does this make sense? Unfortunately, I think this does make sense. I'm gonna just have to pass each of these arguments 3 times, I think. 1 to each vertex. Each vertex is going to need to know all 3 points in its own curve, and all 3 points in the previous, and all 3 points in the following curve. And that's annoying. So the length of this is lin points. I need to basically multiply all these by 3. But what was the problem it had? 433 into shape 333. Since it must have split it up like this. And that is in fact too many. Wait, no it's not. From shape 4 by 3 by 3. Stroke data at previous point should be... Oh wait, that makes sense. Because the length of that array is different. So I'm gonna want to pass in the point. I don't need the previous point and the next point. Yeah, I'm gonna just need the entire curve anyway. So I'm gonna take those out. So with that, let me try not setting any of this. Okay. So now, point of this, I'm going to pass in this previous curve 3 times, then the current curve 3 times, and the next curve 3 times. And try to break there instead. So I do different curves. That's all the curves. So there's four entries. And this is 12 points. So I do need to multiply by 3. If I do np.roll curves 1, axis is 0. That rolls it down once. Okay, all I need to do is like v-stack this. If I did np.repeat, I think. Curves axis equals 0. I think by default it does axis equals like the highest axis. Okay, that's what I have to do. Isn't that a ton of data I'm passing? I guess it would have to be passed either way. Yeah. Well, each vertex is basically taking this much data. So 9 times 3 is 27, so 30 points. 30 floats per point. Yeah, that's kind of a lot. That is kind of a lot. I wonder if there's a way to optimize this using an index buffer. I'm not going to deal with doing that now. Basically, all these have to be np.repeated though. Also, what happens if I don't put x equals 0? And it does something dumb. Yeah, okay. Repeat this 3, x equals 0. This 3x is equals 0. Great. Okay, I'm gonna do with this with actually points now. See how much this loses its mind. It's called stroke data. If I do current curve, okay, so that's totally right. For each of these, the current curve is just the line itself. And actually, all of these will be pretty boring, I guess. So it should just be the same thing over and over. Yeah. But now I don't need P anymore. I don't think I need the points variable. Oh, well, kind of. Just because I need its length. Although, shouldn't this be using shape? Ah, whatever, I won't change that. I guess this could be NPPC. Nah, I don't need that. If that number ends up changing, we're gonna have a lot more stuff to deal with anyway. Stroke data point. Okay, so now I think I can check next curve at 0 at 0. What should that be? Well, the next curve is just the current curve. Although I also don't know the current curve. I'm just gonna print it. One zero zero two 103 0 0. So I'm gonna see if I can turn this red. Great. If I increment this should be 0. Increment this should be 0. One 0, this should be 2. One. And 0. And this 3. Zero, 0. So that's right. And that's right. Great. And just to make sure, if one of these was set wrong, this should turn to blue. Okay, cool. Well, I managed to pass all that data. Okay, all of that. And I didn't even get to any of the geometry yet. Man. Color stroke with unit normal. Yeah, that's fine. Anyway, I guess I don't need the attributes thing anymore. That's good. So I can just pass it like that. Okay, that's great. Even though most of that was just fiddling around with NumPy, that's a lot of progress. Because now I can start computing those 5 points. Yeah, now I can start computing those 5 points. And actually trying to get the shader to work. Great, so thanks for watching, everyone who did. Yeah, and I'm gonna call it here.